We have made it to question number 31 on the Unit 9 Circles Review page. Question number 31. Using the diagram, what are the values of x and y? Oh, you've seen a diagram like this before. These can be very challenging. Class, the only way to solve these is to recognize some of the properties that you learned in this unit. The main one in this case is the properties of inscribed angles. So let's take a look at this. We only know the measure of one inscribed angle, angle B, and that value is 2x. So we know something about the intercepted arc. It's twice the measure of the inscribed angle. Okay, that means the measure of arc AC, must be equal to 2 times the measure of its inscribed angle, so 2 times 2x. So we know the measure of arc AC is 4x. But we're also told that the measure of arc AC is 8y. So we know, we know that 4x is equal to 8y. Well, let's just get x by itself here. Divide both sides by 4, and therefore we know that x equals 2y. Now that's our important piece of information right here. We've just figured out what is the relationship between x and y. So if x is equal to 2y, if you look at our circumference of our circle, we've got 6y, we've got 8y, and then we've got this messed up here, this 4x. So if you added those three expressions together, you should get 360 degrees. Let's do that. 5x plus 6y plus 8y has to equal 360 degrees. We can combine like terms here. We've got 6y and 8y. So we can rewrite this as 5x plus, that's 14y equals 360. Now we can't solve this equation because it has two variables, but we know that x is equal to 2y. That means we can substitute that in here for x. We can substitute 2y for x. So let's go ahead and do that. This is going to be now 5 times 2y plus 14y equals 360. We can distribute here. 5 times 2y is 10y plus 14y equals 360. We've got some like terms now that we can combine. Therefore 24y equals 360 degrees. Divide both sides by 24 and you end up with, let's put our final answer in dark blue, you end up with y equals 15. So we found out what our y value is. Well, now to find our x value, all we do is plug it into an equation. Well, we've already got this equation, x equals 2y. So I can actually write this equation over here on the side. We know that x equals 2y, and we'll plug in y, so x equals 2 times 15, and that means x equals 30. Now for the final check, class, if you want to do this, go ahead and check this out. Let's plug x in here. 2 times 30 would be 60 degrees. 8 times 15, I don't know why, but it's early this morning. I'm having a hard time doing math in my head. 8 times 15 equals 120. And that looks good. We see the measure of the arc AC is twice the measure of the inscribed angle that intercepts it. So we've got our answer. X is 30, y is 15. Let's go ahead and move on to the Pizza problem. A local pizza palace. At the local pizza palace, you have a choice of the following two slices of pizza. We've got slice A, we know the radius, we know the central angle or the degrees, and we know how much it costs. And then we have slice B, radius, central angle, and cost. First thing it says is calculate the area of each slice. Let's do that right now. So the area of slice A, we're going to have to know the total area of the pizza first. So the area of the whole pizza is going to be pi r squared, which is pi times 10 squared, which is 100 pi inches squared. There's our area of our first pizza. That's the whole pizza now. Now let's figure out the area of one slice. This particular slice, sorry. So the total area is 100 pi. What fraction of the pizza are we cutting out? We're cutting out 48 degrees out of a total of 360 degrees. And that's going to be approximately 41.9 inches squared. Alright, let's take the second piece. Figure out the area of the whole pizza first. It's going to be pi r squared is equal to pi, oops, that's not pi, pi times 8 squared, and that's going to be 64 pi inches squared. Let's figure out the area of just the one piece we want now. The whole pizza is 64 pi inches squared. We're going to multiply it times, okay, we're cutting out 62 degrees out of a total of 360 degrees, and that's going to be approximately 34.6 inches squared. So first thing it told us to do was to find the area of each piece, and we just figured that out. This one's 41.9 inches squared, and slice B is 36.4 inches squared. Now it says, compare the cost per square inch, cost per square inch, and determine which slice is the better value. Now class, a couple things you're going to realize here is you can't determine the better value based on just the price. I mean, clearly slice B is cheaper, but what if it's half the size? Then you're not getting very much for your money. So you can't look at that. And you can't just look at degrees. Can't say, oh, the better value is slice B because it has 62 degrees. What if the diameter is really small or the radius is really small? It's going to be a very tiny piece. So you can't look at price, and you can't just look at degrees. And you certainly just can't look at radius, because who knows how much of this piece of this pizza we have. So you're going to have to compare cost per square inch. That's going to be our determinant of which piece is of better value. So what I want to show you here is you're going to put cost, which is dollars, right? Dollars per square inch, or inches squared. So all we got to do is plug in the values that we know. Look at slice A. Slice A, the cost for slice A is $1.90. And the square inches for slice A is 41.9. Let's put that on our calculator. 1.9 divided by 41.9. And you're going to get approximately 0.045. Let's check that real quick. $1.90 divided by 41.9 square inches, 0.045. We can round it to 3 decimal places. You have to do that, class, because this is a very small number, so you can't just round it to 0.0. And if you move the decimal over 2 places, that's like multiplying it times 100. That will change this from dollars. Right now this is in dollars. This is $0.045. If we move the decimal over 2 places, we're going to get it in pennies. So 4.5 cents per square inch. Let's take a look at slice B. So for slice B, we're going to also do cost per square inch. Slice B is, what does slice B cost? $1.75 over a total area of 34.6 inches squared. Put that in our calculator, we will get approximately 0.051. Multiply that by 100 to change it to cents, and we're going to get 5.1 cents. Now take a look. Slice A is only costing you 4.5 cents per square inch. Slice B is costing you 5.1 cents per square inch. This one is clearly the better value. We're paying less money for the same square inch. And think about this, a square inch of pizza is going to be 1 inch on this part and 1 inch on this part. That's cheaper for slice A than that same square inch would cost for slice B. So our final answer should be something like this. You can write this however you want, but I'll put on here slice A is the better value because, here's our evidence, there's our conclusion, here's our evidence, because it only costs 4.5 cents per, and I'm going to abbreviate this, per square inch compared to 5.1 cents per square inch for slice B. So there's a good explanation. You have lots of ways to write this, but I want to show you. There's my answer. Slice A is the better value. Here's my evidence, because it only costs 4.5 cents per square inch compared to 5.1 cents per square inch for slice B.